This is a video that will explain the practice questions for your booklet at the back of your booklet for mostly area. Now this is question number 4, where you're asked to revisit the diagram from question 1 and to find the area this time. Now in your head, I need you to understand that whenever I ask you for the area of something, I'm looking for the coverage inside the walls or inside the outer perimeter. So basically when you have an irregular shape like this, and you will get an irregular shape for 99% of your questions, because just finding the area of a rectangle is kind of boring, you need to take your diagram and divide it up into pieces. So I'm going to draw a line, and I'm going to cut this diagram into rectangles. There's more than one way to cut it, and no matter which way you do it, you would get the exact same answer. Guaranteed. I can show you both ways. Say I cut it here and here, I would have to be able to know the dimensions of all the sides. 13 by the upper, I have to find all the missing lengths here. So first of all, I need to know the distance from here down to here. If it's 20 all the way to the top from the bottom and 13 down, that side would be 7 meters, which would be good. I could find then the area of this shape, which is a rectangle. We'll call that figure 1. And I'm going to find the area of figure 1, knowing the formula is length times width. The length is 24, and the width is 7. So 24 by 7 is 168. Meters by meters is square meters. Now I've got to find another shape. Let's say I find this one next, another rectangle. I've got to know both the dimensions of each side. So I have to start with, okay, the height is 13. What about this side? Like in the previous video, if the whole bottom is 24 and we have 12 from along here and 8 to here, that's 20. So this distance here must be 4, because that top line here and the line 12 and the line 8 must all add to give you the bottom. So my second figure, number 2, would be another rectangle, length times width, so it's going to be 13 by 4. And 13 by 4 is going to give you an area of 52 square meters. The last shape is number 3, and that one I've got to know both the length and the width to do it. I have the width of 8, and now I need the length. So to find from here to here, we did also in the previous video, and if it's 7 from here down and the whole thing is 24, then 24 minus 7 is 17. So the area of figure 3, which would be the length times the width of 8 by 17, 8 times 17 is 136 square meters. So the area in total is going to be the sum of all 3 of those dimensions. So 168 plus 52 plus 136, which is 356 square meters. Now if you were thinking you would have preferred to divide this up a different way and done this shape and the small one in the middle and then this long shape, that also could have been done. You would have had 4 by 20 here. In the middle, you would have had 12 by 7. And the upper would have been 8 by 24. you do the math on that, 8 by 24 is 192, 12 by 7 is 84, 4 by 20 is 80. When you add it all together, you would get 356 square meters as well. So it doesn't matter how you cut it up, but what does matter is that the method you choose to divide it into, you have to make sure that all the dimensions you need are able to be found. Otherwise, you're chasing your tail. So cut it up wisely. The next question asks you to revisit this diagram. We did this one for perimeter earlier. Now we're going to do it again for area. So to solve for the area of any diagram, you've got to remember that area means coverage. All things must be covered. You're going to have a semicircle, and then a rectangle. Now you can look at it as one semicircle and another semicircle, or you could look at it as a whole circle. It doesn't matter, you get the same answer. But what you do recognize, I'm sure, is that there's two figures to deal with. So the area of the rectangle, we'll call that green area number 1, is found by taking the length by the width. The length of the whole bottom we know to be 15, and the length of the side, the upward, of course, is 7. So 15 times 7 will give us the area in square millimeters, which is 105 square millimeters. Now the area of a circle is found by taking the value of pi, which is your constant, 3.1415, so on, times the radius this time, but the radius must be squared. So that worked out to be pi times the radius squared. So my diagram seems to have lost all of its color, which is a technical glitch. So we'll do the area of the light blue. Now the radius, we need to know the radius of the circle. The radius is half of the diameter. We found in the previous video that if the whole length is 15, 15 minus 3 and 3 makes a diameter 9 across the center of the circle. So the radius then would have to be 4.5. So on your calculator, you got to make sure that the 4.5 is what you square, not pi times 4.5, and then square it. Only the r is squared. So 4.5 times 4.5, or 4.5 squared, times pi should give you the answer, which is going to be 63.61725, and that's the area in square millimeters. Now the instructions, do it the nearest hundredths. So we're going to add the area of the inside rectangle, which was green, to the area of, I just did the whole circle because I knew it was two parts. You could have also taken the area of half the circle, dividing it by 2, and then adding 2 together. The grand total will be 168.6172, blah, blah, blah. That is square millimeters, nearest hundredths. That 7 is going to round the 1 up to a 2. So 168.62 square millimeters. And that's the area of the irregularly shaped diagram. Question 6 says, a spectacular piece of graffiti is painted onto the pavement of an old abandoned building, and the parking lot is 35 meters by 52 meters wide. That's the white area in the diagram. It's surrounded by a flower garden, which is the gray area, and the flower garden is 55 centimeters in width. Our job is to find the fencing required if we want to put the fence outside the flower garden, which means on the outside edge all the way around. So to find the outside edge, fencing is a clever way to ask about perimeter. To find the perimeter, you need to know the lengths of all the sides. To find lengths of the sides, you've got to consider what you're given for information. So first of all, we are told in our diagram that our parking lot is 35 meters wide. That's the inside of the white, it's 35. We're told that the other dimension of our parking lot is 52. So from the bottom all the way along this line, that's 52. Now that's only the white. We need to include the black because the fencing has to go on the outside. The very first thing you should be catching here is the fact that the width of the flower garden is given in centimeters, and that's the distance from here to here. And that is 55 centimeters, which changing that to meters is going to give you 0.55 meters. You also have the same dimension on this side of the flower garden, 0.55 meters. Therefore, to find the whole new width from edge to edge, you're going to have to add the 35 plus 2 widths of the flower garden. So the new width, the new W, is going to be 35 plus 0.55 plus 0.55. Now you may be asking in your head, why didn't you go to centimeters? And that's because the question required the answer in meters. So 35 plus 0.55 plus 0.55 is going to give you a new width of 36.1 meters. The new length, which originally was 52 meters long, if you now include the fact that you have this flower garden, which is 0.55 meters, on the top and the bottom, that's going to give you a new length, a bit longer, a little bit, a meter, 1.1 meters longer, so 53.1 meters for the new length. Now to find the perimeter of a rectangle, you either can add length plus width plus length plus width, or you can do 2 lengths and 2 widths. So 36.1 and 36.1 be 72.2, and 2 widths, sorry, 2, or I just said back it, I think I mixed it up there, but you'd have 2 widths, 72.2, you'd have 2 lengths, 106.2, when you add those together you're going to get 178.4 178.4 meters is your perimeter. I'm going to finish that question. That's just a bit of a screw up. That's your perimeter on the outside edge, the green. Now, to do the area on the inside, or the area shaded between two figures, you could potentially cut it up into a bunch of rectangles. But in fact, the easiest way to do this is to find the area of the whole figure, which would be the new width of 36.1 and the new length 53.1. If you do the area of the black and the white together, you would get all of it. Now if you want to find the area of the white, that would be easy because we know those lengths to be something specific of 35 and 52. So let's do the area of the graffiti. The area of the graffiti would be your inside 35 by 52, which is 1820 square meters. Now the area of the entire park, the graffiti, plus the flower garden, would be the outside times the outside, 36.1 times 53.1, which is 1691 square meters. To find the area of the black, you would subtract the entire area minus the white, and that would give you the area of the shaded region. So the area of the shaded region would be 1916.91 minus the 1820, which works out to be 96.91 square meters. So this lesson, you're meant to find, whenever you want to find the area between two shaded figures, you should find the area of the entire shape minus the area of the inside. And that way, it won't matter if the inside shape is something you can cut up into pieces or not. Just find the inside by doing the outside, find the shaded, rather, by doing the outside minus the inside. And that'll always give you the area in between. I'll do one more video for the last two questions.